calculate the percent composition of nitric acid, HNO3. What is the meaning of the formula HNO3? It means that in each molecule there is one hydrogen atom bonded to one nitrogen atom bonded to three oxygen atoms. In other words, the particle ratio of hydrogen is to nitrogen is to oxygen is 1 is to 1 is to 3. This can be written as 1 atom is to 1 atom is to 3 atoms, as shown in this picture. But if instead we would have a whole mole, which I cannot draw, but if we had 6,02 times 10 to the power 23 of these atoms, then we would have within that a mole of hydrogen atoms, a mole of nitrogen atoms, and 3 moles of oxygen atoms. So we can see that an atom ratio and a mole ratio for a particular substance is always the same ratio, and we can rather than just call it a particle ratio, because atoms and moles are two different ways which have a relationship between them of expressing particles and ratios between particles. However, what is the meaning of percent composition? Percent composition is a ratio by mass, not by particles. The formula gives us a particle ratio, 1 is to 1 is to 3. But what they are asking us to do in this question is to convert this particle ratio into a mass ratio. How many grams of hydrogen are found in every molecule in comparison to how many grams of nitrogen are found in there, in comparison to how many grams of oxygen are found in there, and then we must express that as a percentage. So we know the particle ratio already of nitric acid, HNO3, and we need to convert that into a mass ratio. What can help us to do that? Well, by looking at the molar masses on the periodic table, we can know the mass of each element per mole. So we know that 1 mole of hydrogen atoms has a mass of 1 gram, whereas 1 mole of nitrogen atoms has a mass of 14 grams, and 1 mole of oxygen atoms has a mass of 16 grams. So what we need to ask ourselves now is, very simply, 1 mole of hydrogen, what's its mass going to be? 1 mole of nitrogen, what's its mass going to be? And 3 moles is the only one that's slightly tricky. 3 moles of oxygen atoms, what would that mass be? Answer that before you continue with this video. You should have found that, of course, 1 mole of hydrogen has a mass of 1 grams. 1 mole of nitrogen has a mass of 14 grams, and 3 moles of oxygen has a mass of 16 times 3, which is 48 grams. So here we now have the mass ratio in nitric acid. 1 gram H for every 14 grams N for every 48 grams O. Notice that is quite different to the particle ratio. 1 mole H is to 1 mole nitrogen is to 3 mole O. Actually, these two ratios are equivalent. They're just given in different forms. The top one is a particle ratio, the bottom one is a mass ratio, but they are actually equivalent to one another. Now, if we are asked to give the mass ratio in a percentage form, we remember that percentage means part divided by whole times 100. So we need to know what is the total mass of a whole mole of HNO3. And we simply get that by adding the individual masses for a mole. This, of course, all refers to 1 mole. 1 mole of HNO3. 1 mole of HNO3 would contain 1 gram of H, which is 1 mole of H, 14 grams of N, which is 1 mole of N, and 48 grams of O, which is 3 moles of O. And a whole mole of HNO3 would altogether have a mass of 63 grams. So now we simply have to find out what fraction of 63 of the whole is a 1 gram and express that as a percentage, and the same for the other values. Pause the video until you've got the answers yourself. This is how we calculate the percentage of each component. And here we have the answers. The percent composition of HNO3 is 1,6% of the mass comes from the hydrogen inside the nitric acid. 22,2% of the mass is contributed to by the nitrogen atoms. And the remainder, 76,2% of the whole mass, comes from the oxygen that is inside the molecules.